Welcome to our movie slash film that we are doing together as a partner.
This ain't no movie.
This ain't no movie, bro.
This is film.
It's film.
Straight improv right now.
This is Donald Bowman's and Zach Mata's chemistry project.
The chemistry project. Best one. Like, I don't care about any other video. This is the best one right here.
Haley had that guitar. Cuba had some artillery person.
They got some
uppercutter. That's not important right now because we are doing our project.
Okay.
We're doing it over moles. Okay.
What is a mole? What's a mole, Donald?
What a mole is 6.02 times 10 to the 23rd atoms or anything.
Like out of any chemical, like anything.
Anything.
Formula.
Say like you can have 6.02 times 10 to the 23rd of this milk carton, and it'll fill up this room, this whole school, maybe San Angelo, but don't quote me on that, all right?
But our atoms like super little. So I mean that's a lot, but it doesn't fill up that much. I mean, there's probably like a lot more just in that milk carton right there.
There's not. So I'll put it that way.
Yeah, there is.
There is. Okay.
All right.
Okay, but Avogadro's number is 6.02 times 10 to the 23rd, and that is 1 mole of something. Okay. I'm gonna go.
As you said before, that's a huge number right there. All them zeros, as you can see, that's 1 mole of something, of anything, and that's in atoms.
Okay. A mole is a unit. A mole can be an atom, molecules, or formula units. Okay, so it's like 602 000 000 000 000 000 of anything.
Any more zeros?
Anything.
Any more zeros?
No, 26 or 23.
Okay.
23 zeros. Okay. A mole of anything has a mass, it occupies space and volume, and is an amount. Okay. Classify mass for me, Zach Mata.
Mass is how much space an object takes up. I don't know. Why are you asking me this?
You made us look stupid right there, but it's okay, Mata, because I will help you out. Because this is a informal video, you know?
Man, I don't know this stuff, man. Teach me.
So mass is like a gram, you know?
Yeah.
It's like a gram of something. Say, you know, when you're back in there in lab, you got to measure this Cheeto puff. I don't know why you said that, but you got to put it on the mass gram, and you do it. Okay, and it also occupies space or volume. Like, say, like, you got this box.
Why don't you strap this?
Okay, you got this big old box, and in this box contains books. This is knowledge. This is actually dictionary.
Stay in school, kids.
Yes, stay in school. But it is a box, and the stuff in this box occupies its space and its volume. That's what it does. That's what it does. Okay. Okay, we're about to break it down for you right now. 1 mole of carbon. 1 mole is 12 grams, 0.01. So that's 12.01 grams of carbon in 1 mole. And that's just 1 mole.
1 mole.
And 1 mole of carbon occupies 22.4 liters of carbon. So that's like more than your liter drink that you get. So that's just filled with carbon. You got to buy 22.4 of those to get those liters.
Yep.
And also,
Like
1 mole of carbon has 6.02 times 10 to the 23rd atoms carbon.
Or
now that
Avogadro's
number.
Man, will you
Avogadro's number.
Will you ever look top?
Bro, I'm sorry, bro. I'm sorry. Okay, but yes, you'll see this number a lot. 6.02 to the 23rd atoms. Because that's just Avogadro's number, and Avogadro is moles.
Like I said before, that Avogadro's number, that's the number of atoms in 1 mole of neon. Then when you look at neon, same number also applies for liters when it comes to moles. You got 22.4 liters of gas in 1 atom of neon. And then that great number right there, that's how many grams you got 1 mole of neon.
20.2 grams of neon in 1 mole. Okay, now the next slide it is going to be a little bit different, but not by much, and I'm pretty sure you can tell. Mata.
Again, Avogadro's number 6.02 times 10 to the 23rd atoms. Then you got that great leader's number of 22.4 in a 1 mole.
Okay, but like the thing that changes is the grams. Okay, I'm gonna flash you back to the neon. Okay, you see 1 mole of neon is 20.2 grams. Now we're gonna flash back forward, because you went back and going forward. Okay, I don't know if you got that, but I just want to explain. Okay, 1 mole of oxygen is 32 grams, but not 1 mole, because it's a diatomic. Because that 2 at the bottom of the 0 or the O, that means it's a diatomic. So 1 mole, so half a mole, I would say, of oxygen is just 16. But since it's a diatomic, you would have 2 of them, which makes 1 mole, and you have 32 grams.
This is a compound right here. You got NaCl, or sodium chloride, which is also known as table salt.
Table salt, yes.
In 1 mole of table salt, there's 6.02 times 10 to the 23rd atoms in 1 mole of it. Then again, you also got 22.4 liters of gas in 1 mole of the table salt. And then you see the gram change, just like in all numbers, because the grams are not the same in all of the atoms.
Okay, just think about this Dickie's burger you just ate at lunch has NaCl in it. Okay,
Salt.
it's salt.
Thank you.
That's salt. And like 1 mole of that salt in this burger would be 58.5 grams. Okay, this is a little FYI to help you out. Alright? The human body contains 7 atoms. That is 7 times 10 to the 27th number of atoms. And that is approximately, I don't know how to say that word. Say it for me, Mata.
Approximately.
There you go. See, that's why I'm partners with them. Okay. 11,628 moles of atoms. Okay? But your body is 99% carbon, hydrogen, and oxygen inside your body. You see that little body? All that contains that number of atoms, which is 7 times 10 to the 27th atoms. And it is 99% carbon, hydrogen, and oxygen. Okay, this is going to conclude our video for Miss A's chemistry project. And hope you learned something. And what else you got to tell them, Mata?
This better be 100.